In our last video, we checked the Faraday law and the Lenz law. Now we'll describe how they are causing the change or how the EMF is producing. See, in the first case, we are taking an example of a magnet which is going towards a loop, and in the second, we are taking when the magnet is going outward from the loop. See, when we make the forward motion of the magnet, then the number of magnetic lines increase through the loop. Means if we make the magnet to go towards the loop, then obviously the number of lines will increase. This is the basic. But this magnet lines increase will produce the magnetic flux to increase, because we know phi is equal to B dot dA, close integration. So obviously if the magnetic lines increase, then the magnetic flux will also increase, and SI unit of magnetic flux is Weber. These things is to remember. So this magnetic flux change will produce EMF in the circuit, which will produce electric current. Now this is important, because if we are changing the magnetic flux, then this will produce an EMF, and this EMF in the circuit will produce electric current. Okay, and this electric current will produce magnetic field. Means the electric current which is produced, it will produce an itself its own magnetic field, which I am telling in the previous video, that it will produce its own magnetic field to oppose the change in the flux which is produced by producing push to the magnet. Means it will produce its own magnetic field, and this magnetic field will uh, oppose, means the flux which is changing here, this flux he will oppose the change in flux by pushing the magnet. Means why, how this becoming, see, if the magnet is coming here, then the north and south pole will, from the north the magnetic lines of force will getting outside, and these are getting inside to the loop, and as a result a current is flowing in the anti-clockwise direction. See, in the anti-clockwise direction, and this anti-clockwise direction current will produce a magnetic field in the north south direction, means here in this direction. See, if we make the right hand thumb rule, see, if we just curl our fingers along the current, then the magnetic field will be along like this. So this will be the uh, north, and this will be the south. So see, here the north is becoming here, because the magnetic field line is this. Okay, so the north is here and the south is here, and this north will oppose this north, so this will oppose the magnet to come forward or to make the flux increase, so it will oppose the change. And similarly, if we make the magnet to go outside, then the number of lines will decrease, and this is also a change. So this change will also create EMF. Remember, EMF depends only on the change. Means if there is a change, then the EMF will create. It does not depend that it is increasing or decreasing. If change, then the EMF increase, so it will try to oppose the change. Similarly, when the magnet is moving away from the coil, then the number of magnetic lines of force decrease, but the EMF will still produce, because due to the change of the magnetic flux are decreasing, but it is a change. So the current will induced in the clockwise direction. So now the current will induced, see, now the current will induced in the clockwise direction, because if in the clockwise direction, see, then clockwise, if we make the clockwise this, then the current this clockwise. So if we'll the magnetic field in this direction, so magnetic field in this direction means north is becoming here and south is becoming here. So this south will attract the north, and if this attract the north, then the magnet will not able to get away from the loop. So this will also try to oppose the magnet in this way. So in any case, it will try to oppose the magnet, because to oppose the change. So this is the direction of the negative sign in the Faraday law, because that's Lenz law is telling us about.